Alright, so on a step coming up very soon, we'll be ready to add the controller into the 3D test game. So I did take a moment and speed it up a little. I set the timeouts to 0.2. That seemed plenty fast enough, and I got down a half second is plenty enough to boot up. Probably could go even shorter, but I got down to that, and there's still a slight wait, but I think if there was a splash screen showing, it wouldn't seem like much of a wait at all. A lot quicker than it was. Could probably be even faster, but that's still good for testing. Just have to go in and try some different numbers. Alright, so now back to the 3D game and adding the controller into it. Okay, so when the last video left off, it was at this point. So we set up our Panda3D window and brought in a couple 3D objects to work with. But the camera's not in a great position there, so I'm going to go ahead and set a position for the camera. Let's see, and our show base object, well, the core one is a base object, and then the show base object has some, is an expansion of that automatically shows on the screen and stuff, so there's less things for us to manually activate. But that core base object has a camera. We kind of looked at that, so we can call the self.camera, set position. Oh, I'm just going to go off to the side a little bit, maybe 50 in the X, negative 35 in the Y, and 10 in the Z. Maybe we'll be able to see that, see the whole scene from there. And then, obviously, before too long, the controller will have control of that. And then we also have a look at function built into the camera. So I'm just going to take the camera and set it off to the side somewhere, looking back at the origin. Give this a test, see if those numbers work. For now, we just need to see the whole scene. That'll work. I guess I can move it back a little more. 70, negative 65, something like that. Let's see what this looks like. That's a little too far. I just need to see the character to get started, and before long we'll be taking direct control over the camera. So I think those first numbers kind of worked. Just offset a little bit where we can see the character and land, and that way when the game starts, we'll be able to start moving immediately. So now we can bring in our controller object, and I just copied that module over to this same folder to make it easy to import here without actually adding the Python libraries or anything. So basic control unit, import everything. That way I don't have to type basic control unit dot basic control unit, and we'll assign it to a data field. Self.controller equals a basic control unit. So now that should go ahead and initialize. We haven't got to the movements yet, but we should see all the connection things. Opens the window. Oh, yeah, and over in the background it's scanning for ports. Found a few, connected to port 6, and loads the game in. Yeah, so that gets us started. I guess the next step is to move the character around. Well, for this test, I'm going to bypass the big physics engine and just do some basic movements. I'm going to set gravity, manually set gravity, just have a vector going down until the character collides with the ground. That's really the only physics we need here. and then set up some basic movements on the controls and avoid a entire physics engine. Though Panda3D does have choices of physics engines to work with. There's a built-in one, but it also comes with open physics. Something. I should pull up the API. Instead of just trying to tell you from memory, why don't I actually pull up the API and point at what it is? So physics in Panda3D. I think this will. So there's. Nope, that's not the one I wanted. This one? Perhaps. Here we go. So there's a built-in one. The bullet physics engine is a fairly common one that's used in a lot of game engines. It's been around for a while, very powerful, and is built right into Panda3D. Or we also have Open Dynamics physics engine. Bullet shows up in a lot of game engines, so that's kind of a good one to work with. But I think since we don't need many physics, I'm just going to use some simple collisions from Panda's built-in physics engine instead of going with Bullet and doing all the full rigid bodies and a bunch of complicated physics. I'm just going to use some simple collisions from Panda's 3D built-in physics and then manually type in the physics needed for this test, which I think is mostly just gravity. So just have something accelerating the character downward at 9.8 meters per second, and that's probably the only physics we'll need. So we have a way to control it. Boots up a little bit quicker. Still need to do some things to speed that up, I guess. And the camera looking at our character when we start. So now we're ready to start moving the character around. Yeah, and if there was a splash screen with like a meter going, that 5 seconds there wouldn't seem nearly as long. So let's get started moving the character. So Panda3D has a task manager built in to work with all the tasks. So the first thing here, let's set up just a little default test movement thing. So I'm going to define a function called move character. And obviously it's in the object, so it needs to take in the self. And this will be a task to carry out. So we'll have a task passed in from the task manager. And to decide how far to move. So what I'm going to do is just do a little bit of math. So the task is basically, that's each frame of the game. So we're going to take task.time, so whichever task we passed in, and maybe try multiplying by 5. And that'll give us a distance so that, like after the first frame of the game, it's 1 times 5. And then the second frame of the game, 2 times 5. And the third frame, 3 times 5. And I think you see where that's going, so that this distance is going to keep incrementing with each frame of the game. And then we'll apply that to the human object. So self.human.setPosition. And I'll just move off in the X. So step size. And I'll keep Y and Z the same. And then when we're done with the task, we always have to return task.continue. Well, abbreviated. But that means finished with this task, continue on to the next one. And then once we have our task set up, there is a manager. So self.taskManager, task mgr, short for manager. And it has this method add. So now we can just add that task. Self.move character. And then we need to give it a tag so that it can, well, the tags are used internally. Even if we're not going to use the tag, we still have to apply it. And, well, you might notice that the strings are a different color. Using the single quote thing in Python that often happens, Notepad++ was giving me a really weird color. So I did go up to settings and style and change the string and character to what I feel is a more normal color for strings. Just green strings. It seems like I see that more often, so now I don't have those weird colors. But so we created a task, and then we just add it to the task manager, and then it should run in the main loop of our game now. So let's give that a test. So Python test1.py. Well, it has to boot up the controller, which seems to take the longest searching for ports, but once it gets all of them, it's there. Okay, so there the character moves off to the left. So now we just need to adjust this so that the step size increases by what we feed in on the controllers. The controller values from the controller. Okay, between scenes there I did do what should seem as obvious testing of checking what the X and positive and negative X and Y directions are. So now we can move this, adjust this movement over to the controller rather than the timer. And well, immediately it should be apparent that we won't want to use that timer, otherwise it's going to get faster and faster and faster. So we'll just set a speed variable. Well, 5 seemed to work. I'll start at 5. That's probably way too fast. We'll adjust it though. And so instead of a step size, we'll do a step X and a step Y. So we'll take that speed and multiply it by whatever the self.controller.getX method gives us, which is that between negative and positive 100, the percent coming from the controller times the speed. Oh yeah, that's going to be way too big. Because if we multiply that by 100, we'd have moved a speed of 500. So 1 is probably still way too fast because that's going to move by 100 pixels. But the same thing for the Y. So whatever our speed is, we'll adjust that in a moment, and we'll multiply that by whatever the controller says the Y value is. So obviously, eventually we'd probably want to use the X to turn, and then the Y moves forward and backwards, depending on how we're turning, but we'll ease into that and start by just moving the X and Y directions the way we're looking at it from the camera's position. Start with an easy one to make sure the controller's working, and then we'll build up on it. So once we know the step size, I'm going to create a variable for the new X position, which is the human's old X position. So we'll get the X position of the human, and then add that new step size we found in the X direction. And same thing for the Y. The new Y is going to be assigned wherever the human already was at, the current position plus that step in the Y direction. And then self.human. Well, we saw set position for that quick test a moment ago. Set position immediately jumps to the next position, which if it's really short, it's going to flow together and look right on the screen, but the computer still doesn't notice any points in between, so collisions could be missed. So along with set position, we also have set fluid position. Might as well start using that since we're past the very first test. And with fluid position, as far as looking at it, it looks the same. The character jumps from one spot to the next, so we want to make those very small jumps so that after a lot of frames of the game, it's going to look like smooth movement. But with fluid position, the computer knows the character passed through every spot in between, which is important for collision detection, because we don't want to just pass by our collision and completely miss it. Otherwise, it's kind of the same thing. Just set the position to the X, Y, and Z positions, and we're just going to move it by whatever the controller says times our speed, and then add that to the previous position, and do the fluid movement so the computer knows we were at every spot in between as well. So I'm going to give that a save, clear this up for the next run, and run Python test1.py. So as that loads up, seemed to take a long time that time. So if I push up, whoop, it goes backwards. So that probably needs to be the negative, and down goes forwards. And I was barely moving the controller, so 1 is way too fast. There's pushing right moves left, because we're kind of looking at the front of the character here. So pushing left moves to the character's right, and I'm just barely tapping it. So if I move it all the way, so let's come back here. That's the full speed, so 1 is way too fast. Let's try 0.1, because we're multiplying it by 100. So when we multiply that by 100, well, let's try 0.5, 0.05. So when we multiply that by 100, it's like 5 pixels at a time, if the controller is pressed all the way. Oh, and those directions seem backwards, so let's make those negative. And come over here and give this another run. Yeah, the delay there is in the regular for loop, so I'm not quite sure what's taking so long there. Now that might be a little too slow, but pushing up moves forward as far from the character's perspective. Down is backwards, to the right and to the left. So that looks good, but that's a little too slow. So let's try 0.1. See where that goes. That'll work. So moving left and right. I guess we'll probably, instead of just moving on the global coordinate axis, the next step is probably to use left and right on the joystick to turn the character, and then up and down to move it forward and backward. Which there's a couple other steps involved, but we can see we are getting the controls, the values from the controller. So really that's enough for a test. I just want to kind of finish some stuff up here so that it's more of a complete game. But up, down, left, and right move the character on this coordinate plane the way it should. So I'm going to go through and make some adjustments, and we'll be back in the next video to do instead of moving left, we'll turn to the left, and then the Y will adjust forward and backward in the direction we're facing.